1 students. Happy Wednesday. Okay, so let's look at these notes from day 1 of triangle proofs. These are day 1 notes. We're just gonna get a little refresher. If two triangles share a side, when you're doing a proof, you're probably gonna use the reflexive property. If you have vertical angles, then you're probably going to use the vertical angle theorem. If you're given the midpoint or bisects, then you're going to use the definition of midpoint as a reason, or definition of an angle bisector, or your other option is definition of a segment bisector. If you're given parallel lines, remember, then you're probably going to use alternate interior angles to show that two angles are congruent. And if you're proving parts of triangles are congruent, then at the very end, you're going to have those two triangles being equal to each other. Remember, there are 5 theorems that we're going to use in order to show two triangles are congruent. These are just going to be examples of each of those 5. We've got side angle side, side angle side, side angle side. We've got side side side, side side side. We've got angle angle side, angle angle side. We've got side angle side, side side side, angle side angle, angle side angle, angle side angle, and hypotenuse leg for a right triangle only. Hypotenuse leg, right triangle, 1 leg, and then the long side across from the 90-degree angle are equal. If at any point in time you're doing a proof and you get confused about what reasons to use, this is a very important resource. This is a list of all possible reasons. So from day 1 notes, we want to just keep these 2 important resources at our disposal in case if we need them. A list of all possible reasons and just a kind of idea about what you're going to use. Depending on what you're given is going to tell us what we use in the proof. Okay, we're going to move this one now. This document I'm going to move out of the way, and then we'll go to our day 2 notes. Sorry, I got to make this really small. Okay, let's look at our day 2 notes, and let's start off with numbers 1 through 6. I want you to take a second and do these on your own. So you're going to mark the given information. Then remember, we have 3 pieces of information after we mark the given information that we see if we have. Number 1, you check for vertical angles. Number 2, you check for a shared side. And if it's given that lines are parallel, we look for alternate interior angles. So right now, you take the time to do numbers 1 through 6, pause the video, and when you play it again, all the answers will appear for you to check. Okay, so for number 1, angle B is congruent to angle D, and C is the midpoint of BD, so that tells me BC is congruent to DC. So triangle CAB is congruent to CED. I have to mark the vertical angles that I have there. So these 2 triangles are congruent by angle side angle. Number 2, AC bisects angle BCD, so that gives me 2 congruent angles here. It also bisects angle BAD, and I have a shared side I need to mark. So triangle ACB is congruent to ACD by angle side angle again. Number 3, AB is congruent to BC, and BD bisects AC, so that tells me that these 2 segments are congruent, and I have to mark a shared side. So triangle ABD is congruent to CBD by side, side, side. 4, C is the midpoint of BD, so these two segments are congruent. Angle A is congruent to angle E, and I also have vertical angles I could mark congruent here. I can see that triangle BCA is congruent to DCE, and this is by angle side. Lines AB is parallel to CD, so that shows me two parallel lines being cut by a transversal here. So that tells me that the alternate interior angles are congruent. AB is also congruent to CD. So we have a couple options here. Triangle ABC is congruent to triangle ADC. By right now, you can see we have angle side, but we also have a shared side here where you could use angle side angle as well. BD is perpendicular to AC, meaning that they intersect at a 90 degrees angle. AB is BA, is congruent to BC. And I have a shared side here. This is a special case. We've got hypotenuse leg here. So triangle ABD is congruent to triangle CBD by hypotenuse leg. So that was a little just recap. Hopefully you got them all right. Now we're going to move on to actual proofs. If you remember, there's 4 steps to doing a proof. We already did step 1, which is marking the triangles. We did that. Step 2, we decide hypotenuse leg, side, one of the 5 theorems. We've done that too, just like above. Now we're going to write the formal proof and show our justifications and reasons. One of the big rules that we learned is if you mark it, then you mention it in your proof. Every single proof that you write is going to start off with a 2-column proof. 1 column on the left will be statements, 1 column on the right will be reasons, and the first thing that we always write in a proof is this given information. So we're going to write this given information down. Angle 3 is congruent to angle 4, and PQ bisects angle APB. And how do we know this? Because it was given. This will always be the first line of your proof. The given information and the reason will be given. Now that we know the given information, we're going to go mark our triangle. So angle 3 is congruent to angle 4. And PQ bisects APB. So that means these two segments are congruent. Well, I just marked it, so I'm going to mention it. So in step 2, I marked that segment AQ is congruent to segment BQ. And how do I know that? Because it told me PQ bisects angle APB. This is a definition of a segment bisector. Remember, if you mark it, you mention it. So I marked it because I know this to be true, so I'm going to mention it in the proof. And I knew to mark these because it told me it bisects, and that's what a bisector does. It's what a bisector means. Step 3, I've now marked all given information. Now I'm going to look for those 3 other pieces of information that I may possibly have in the figure. And I notice I have a shared side. So I notice that PQ is congruent to PQ. And this is by reflexive property. So number 4, now I've shown that I have congruent sides, angles, and sides. So I can conclude that the 2 triangles are congruent. I can conclude triangle APQ is congruent to triangle BPQ by side, angle, side. So even if you are having a hard time or struggling with the proof, you can at least write down this, and this statement every single time to get a little bit of credit. But there is a very specific path we follow when approaching a proof. First thing you do, write down the given information and state it as given. Then you mark your triangle with the given information. If you mark it, you mention it. So we marked here, we mentioned. The reason is just how. How did I know to mark that these two segments were congruent? Well, because it says there's a bisector, and the definition of the bisector is we get two congruent segments. So if you mark it, you just tell me why you mention it. If you're having a hard time with what reason goes over here, that's where you can visit your day one notes, that table list of reasons, and kind of spark your memory to see if there's anything that you need to mention there. Okay, let's go on to number 2. All right, so the first thing we do is we write our given information. TA is parallel to LD, and TD is parallel to LA, and this is given information. Okay, I'm going to go mark my triangle with this given information now. TA is parallel to LD, and TD is parallel to LA. Okay, given information is marked. Now I'm going to state any information that I may know based off of the 3 things I can look for. Vertical angles, I don't have it. A shared side, I do actually have, so I can use that if I want. Right here, I know that AD, pay attention to corresponding parts, is congruent to DA by the reflexive property. There's my shared side. And then I also know that I have parallel lines, which tells me that the alternate interior angles are congruent. So angle 3 is congruent to angle 4, and angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4, and angle 1 is congruent to angle 2. That's my alternate interior angles. So now I can conclude that my 2 triangles are congruent by angle, side, angle. The triangle ATD is congruent to triangle DLA by angle, side, angle. So step 1, write the given information, then mark the given information. Step 2, look for any of those 3 pieces of information we discussed that you can mark after the given information. Step 3, determine how the 2 triangles are congruent and finish up the proof. So make sure that you're following your systematic steps to help you, because it's easier. Let's do another one. Number 3. Step 1, write that given information. C is the midpoint of AE and BD. This is given. Okay, now I'm going to go mark the given information. So if C is the midpoint of AE, then I know these 2 segments are congruent. And then I also know these 2 segments congruent if it's also the midpoint of BD. So I know AC is congruent to EC. Watch your corresponding parts. And I also know BC is congruent to DC. And this is by the definition of a midpoint. It says midpoint here, so I'm going to mention it. Okay, I'm almost there, but I don't have the 2 triangles congruent. So I look for any of those 3 pieces of information I may have, and I notice I do have vertical angles here. Angle ACB is congruent to angle ECD by vertical angles theorem. And now I realize I have enough information to prove the 2 triangles congruent. Triangle ACB is congruent to triangle ECD by side, angle, side. So remember, step 1, read the given information. Write it down. Mark the given information. If you mark it, you mention it. I marked this based off the given information and I mentioned it. I know that because of definition of midpoint. After you deal with all the given information, you have 3 possible pieces of information that you could then mark on your triangle. I had one of them, which was vertical angles. After I marked the vertical angles, I had enough to prove the 2 triangles are congruent and end the proof. Number 4. Oops. Let's do this. This one's a little bit trickier than the other 2, but that's okay. We just want you to see as many examples as possible. Step 1, TX is perpendicular to AY, and angle 1 is congruent to angle 5. This is all given. Okay, well, if TX is perpendicular to AY, that tells me angle 3 and angle 4 are right angles. And this is because this is a definition of perpendicular lines. That's what perpendicular lines do. Well, if angle 3 and angle 4 are right angles, then they're also congruent. And if you look on your list of reasons, we have a reason there that says all right angles are congruent. So we can use that reason here. Okay, angle 1 and angle 5 were also mentioned as congruent. Now I've got to look for any other piece of information I may possibly have. Do I have vertical angles? No. Do I have parallel lines? No. But do I have a shared side? Yes, I do. I notice TX is congruent to TX. This is our reflexive property. And then I finally realized here that the 2 triangles are congruent. Triangle TAX is congruent to TYX by angle side. So we followed the procedure. Step 1, we wrote the given information. Step 2, we marked the given information, but we broke it down in such a way where we marked it, we mentioned it. Step by step. We know they're both right angles, okay? Then we can conclude, therefore, they're congruent, okay? After that, we had no more given information, and then we said, all right, well, let me look at those 3 possible pieces of information I could use, and we had a shared side, which gave us congruency by angle side. So make sure when you are doing your homework that you take it step by step and you follow the very specific procedure to help you with proofs. This is what your homework looks like. You can notice that on your homework, you have a certain number of boxes already set up for you. So you can go ahead and number your boxes. And worst comes to worst, if anything on your homework, I should see all given information written in the first box with given in the first reason. And I know the last statement is going to be that the triangles are congruent. So if anything, we can have those 3 pieces of information in every single proof, if anything. So we can do a couple together. I wrote that given information. Okay, AD is parallel to BC, so I'm going to mark that. And AB is parallel to CD. Okay, that's all I have. So now I'm going to look at my 3 pieces of information that I'm allowed to mark. Alternate interior angles come with parallel lines, so I know angle 3 is congruent to angle 4, and angle 1 is congruent to angle 2. So angle 3 is congruent to angle 4, angle 1 is congruent to angle 2. And this is by alternate interior angles theorem. Now I look for my other 2 pieces of information. I don't have a vertical angle, but I do have a shared side. Look at your corresponding parts. I can see BD is congruent to DB, and this is my reflexive property. And now I can see that my two triangles are congruent by angle, side, angle. All right, number 2, let's do one more together. If anything, write that given information. DN is congruent to CN, and DA is congruent to CB, and N is the midpoint of AB. This is all given. And I know my last reason is going to be that the two triangles are congruent. Okay, so let's mark it up now. DN is congruent to CN. DA is congruent to CB. And N is the midpoint of AB. That means these two segments are congruent. I marked it, so I'm going to mention it, that segment AN is also congruent to segment BN by definition of the midpoint. It said there's a midpoint, and that's what it means, that it's going to cut that big line in half. And now I can see the two triangles are congruent by side, side, side. Last one we're going to do together. Number 3, you can put your numbers in here. And we can at least do the given. AN bisects angle CNI, and angle CAN is congruent to angle IAN. That's given. And I know my last reason is going to be that, or statement is going to be that these two triangles are congruent. All right, let's mark the given information. AN bisects angle CNI. So AN cuts that big angle in half. So that tells me these two angles are congruent. So I can conclude angle CNA is congruent to angle INA by the definition of an angle bisector. That's what an angle bisector does. It cuts an angle in half. Okay, angle CAN is congruent to IAN. Now I look for one of those 3 pieces of information. Do I have vertical angles? No. Do I have any parallel lines? No. But do I have a shared side? Yes. I can see AN is congruent to AN by reflexive property. Therefore, the two triangles are congruent by angle, side, angle. All right, you guys, so take your time, finish your practice, follow the procedure, and do your best with these proofs. We'll work on them more later. But remember, step 1, write down your given information. Step 2, mark your given information. Kind of decide what approach we're going to take to the proof. Look and see if you have any other possible information you could mark, and finish your proof up. If you mark it, you mention it. Remember that. Save your questions, and I will see you guys tomorrow.